Now let's look at division. Multiplication and division are very related. They look at the same three categories here, but in a different order. So let's look at a question 12 divided by 4. The first number in a division equation is always the total number of things. So this category is going to actually move to the front here. That's always true for division. And let's flip this around. The second number can sometimes refer to the number in each group or the number of groups, so that can vary. So we actually, because of that, have two different types of division that we can look at here. I will explain. So let's look at a word problem, which is going to tell us which category we're in here. Say we have 12 bears, and we want to share them between 4 kiddos. And they, of course, all need to have an equal number of bears, to be fair. In division, we're always having an equal number of things in each group, as well as multiplication. So we know the number of groups actually. In this word problem, it tells us that there are 4 kids. So this number here actually refers to the number of groups. This is our equation to model our word problem. So we know that there are 4 kids, and what it's asking for then is how many bears does each kid get? So that's this here. That puts us in the sharing category of division. So when we're sharing, let's go ahead and try to solve this. How many bears is each child going to get? Well, there's actually 2 ways I can go about this. We have 2 strategies for sharing. One is to eyeball and check. So I'm going to just kind of eyeball these into 4 groups. Do I even have space here? 1, 2, 3, 4. Okay, that looks like about 4 equal groups. And let me check. There's 3 bears for this child, 3 for that child, 3 for that child, and 3 for the 4th child. So great. I eyeballed it and I just checked, and I did divide them into equal groups. And so now, how many things are in each group? How many bears does each child get? Well, each child gets 3. It's all fair, so we're good. So 12 divided by 4 is equal to 3. Now, sometimes it's easier to do a strategy of dealing them out. So in that situation, we're going to have 4 kids, and we're going to kind of deal our bears just like you would deal cards. This works pretty well a lot of the time. So I'm going to say 1 bear for that child, 1 for that child, 1 for there, and 1 there. Second bear for them, second bear for there, second bear, 3 bears for that child, 3 bears for this child, 3 bears for this child, 3 bears for this child, and all my bears are gone, so I am done. So now I can also see, after dealing them out, that each child gets 3 bears. Now, sometimes we actually have word problems where it talks about the grouping method of division. So, for example, it might say, we have 12, we want 12 bells, and that's the total number of things that we want. And we know that bells are sold in boxes of 3 per box, 3 bells per box. That's the way the store sells them. So that actually means that we know that the number of things in each box is, actually I'm going to make it 4. We're going to say that they're sold in boxes of 4 in each box. So then the question is, how many boxes do I have to buy? Because I need 12 bells. And so it's the same question here. We have 12 bells that we want, and we know they're sold with 4 in each box. And so we're looking for how many boxes we need. So here we go. I'm going to go to the store. Of course, we know the answer, but we're going to pretend we don't. And I see all these boxes of bells on the shelf, and there are 4 in each. And I want to know, how many boxes do I need to buy? Well, let's take a look. If I buy 1 box, I've got 4. If I buy a second box, I've got 8. If I buy a third box, I've got 9, 10, 11, 12. Oh, so I don't actually even need to buy these boxes. My answer is 1, 2, 3 boxes. I need to buy 3 groups of 4 in order to get 12 total. Let's take a look at that in a different way. Let's say we're not told actually which kind of way of thinking about division we're looking at, and we get to choose ourselves. So let's look at an equation that was given to us, 10 divided by 2. And here's 10 items. So what my brain thinks to first is I have 10 things and I want to share them between 2 people. That's kind of the way my brain goes. So here's 10. I'm going to put them in 2 different groups. So I'm thinking of 2 actually as the number of groups in this case. And then the question is, how many items are in each group? So I can see here 5 in this group and 5 in the second group. So my answer to 10 split into groups of 2 is 5 per group. That would be the sharing concept. But I can also look at the same exact equation, and if there's no word problem, I could decide to think of it actually as the grouping concept. I can think of it as groups of 2. And how many groups of 2 are going to give me that 10? So notice even that language there kind of refers back to multiplication as well, but all right, so here's my 10 items, and here's one group of 2, a second group of 2, a third group of 2, a fourth group of 2, even the language I'm using here can be helpful, and a fifth group of 2. So I started with 10 things, and I split them into groups of 2, and the number of groups I have is 1, 2, 3, 4, 5. So again, 5 is my answer.